Hi guys. Very happy to see that some brave people still here at Friday afternoon or noon, I would say. So excited to be here. I'm going to talk about I'm going to share some of our experience in developing a 2D based gesture solutions. I'm a co-founder of Superb Reality, as Jeffrey said. And as I mentioned, we'll talk about building a 2D based gesture interaction system that actually works. Okay, so who is this presentation is for? Special presentation is for UX engineers. Probably they'll have a lot of questions afterwards. Data engineers, Superb Reality engineers, Superb Reality competitors. If you're considering becoming a Superb Reality competitor, or you're considering adding a 2D hand interaction to your hardware. We have only 20 minutes, so I'll try to make it quick, and if we have time, I'm going to show you a live demo, hopefully. We'll get to it on this cutie. If you know, it's the HTC Focus integrated with our middleware. Okay, so let's start. Superb Reality was founded by me and Yoav Choshen. Yoav is my friend, and he's a serial entrepreneur, has a lot of experience in consumer electronic. I will go a little bit and talk about my history because it's relevant to the discussion here. So in 2006, I was the algorithm team leader at a company called IDT. We did 2D-based simple interactions. Okay, let's see if it works. Okay, it doesn't work, I think, the video. Why is that? This thing we did in 2007, just simple based touch and gestures. In 2007, I joined a startup company called Omic Interactive. Yeah, thank you. A company called Omic Interactive, where I developed a middleware. For 3D camera, like PrimeSense camera and Canesta camera. At 2009, I became the CTO of a company called PointGrab. At PointGrab, we succeeded in actually launching a large-scale software for gesture interaction. We licensed Samsung, smart TVs, millions of devices, and it was a big thing back in 2012, 2014 and 15. At PointGrab, at IDT, we made about $800 just from licensing our software. At Omic, we did 100,000 K, and at PointGrab, we managed doing $25 million revenues just by licensing a 2D-based gesture software. Okay. So why am I showing you that? Because it's relevant to the experience. I've been working in the gesture field for probably 12 years already. Okay, so if we want to design any kind of input device for AR and VR, so let's talk about the general device. So what are the type of characteristics we want? So there are several. Of course, the device has to be available, right? It has to be always there. If you don't have the controller with you, then you can do nothing. There are other things like intuitive. It has to be immediate. It has to be robust, work all the time. Has to be cheap enough, and there's another factor we keep hearing that is, well, I don't want to embarrass myself doing this in public. Guess what? So if we take a look, let's put the hand gesture aside. If we take a look at the existing control for AR and VR, we see that we have today like touchpads, head tracking, voice commands, accessories. All that has some good characteristics, some bad characteristics, but they all lack the intuitiveness, and they lack the availability. So, of course, the next slide is I'm going to talk about the solution for all that, what we think the solution is. And yeah, it's Tom Cruise, of course. Tom Cruise is the solution to everything. If you remember correctly, 2002, I think. Remember the movie, Minority Report? It was the first time people actually understood what gesture control is. Ever since 2002, every time I was demoing my application or my software, I say, oh, it's like Minority Report. And I say, no, but I say, yeah, give me this and that, and yeah, I want. And so 2002 was a critical point for gesture recognition, but it's also the root of all evil. More about it later on. Okay, so enter the hand tracking and gesture control. So currently, when I'm talking to guys about hand interaction and hand tracking, they said, okay, there is the lip motion, and there's the other stuff. I said, okay, so I think that in psychology, you call this kind of thing is a distortion. The other stuff has a lot of things in it that I'm going to talk about right now. Some of them might surprise you. And this is what I'm going to talk about. When we are trying to, first of all, why gesture recognition, 2D, let's talk about 2D gesture recognition, didn't manage to make like the breakthrough it was supposed to do a few years back. So there's challenges in doing so, right? If there weren't challenges, it'd be easy and everyone would have done it. So, of course, there are technological challenges, and exponentially worse user experience, right? If you're coming from a big company, you know you have that user experience, a UX. And this is a guy everyone is afraid of. So when trying to design this kind of system, then you have to take both into consideration. I will drill down a bit. When talking about technological challenges or issues that we have, I'll go through just a little bit some of the challenges. So of course, when you're using a 2D camera, you always have like a contrast issue. You have like hand shape varieties. CPU is always a limitation, also memory. And the sensor of the camera is also a problem because the resolution of the frame rate, all that. You have cache memory. Floating point calculation is also bad. Lens distortion, it happens. Some cameras have lens distortion. High degrees of freedom for the hand and illumination, auto exposure, but there's a lot of technological barriers that you need to take into consideration. Here are some examples we got from our real users. So as you can see that the actual images that you were getting from the camera has low contrast, overexposure, underexposure, different type of hand shape, different proportions. This is my all-time favorite, and this. So technologically wise, there's a lot of things to take into consideration. I'll talk about it in a few minutes, what our strategy of overcoming this. When talking about UX challenges, the first challenge that we recognized a few years back is misinterpreted requests. Okay, so let's say that you have like a gesture system, and the gesture system says, hey, could you please perform a like gesture in front of me like this? And the user say, oh, okay, I can do that. Here. And let's assume that your gesture system is really sophisticated and say, no, you know what? Can you do a little bit, turn it to the right a little bit? And the user said, I can do that as well. Here. So your system, your software is so sophisticated, it tells, okay, that's good. Can you just close the finger a little bit? Just close a little bit and it will be a perfect like. And the user said, okay, but it still doesn't work. Right? And this is the actual thing that we're getting. So what happened? We asked for something very specific, but users do whatever they want to do. Okay. That's good. So the next challenge, it's mathematical thing that I call it, what the heck was that? Okay? What the heck was that is you're tracking a cloud of points or a trajectory in space. And then you get this. Okay, what is it? The user was trying to do a circle. It was doing this. What the heck was that? The user meant to do something. But how exactly do I take or transform this set of points into an event? I need to make a decision to say, okay, you know what? Now we did he wanted to do a circle, and he wanted to go back. But is this a circle, or I'm not sure. By the way, this problem becomes much more pronounced if you have a lot of points that you track like at the same time, right? If you're tracking, like, for example, all the points of the hand at the same time, then the decision is much more complicated, right? This is images from a paper from SIGGRAPH, 2016. Okay. Another issue that we found when designing a gesture system is multiple meaning. Multiple meaning. So imagine, for example, that's a good one. I like it, the example, the swipe, right? Everyone wants to do a swipe. Swipe right, swipe left, right? So you tell the user to do this, swipe up, and it's just, oh, okay, yeah, I'm doing that, right? Swipe left. So I want a picture to move left. What the software actually see is this. It's moving left, right, left, right, left, right, right? So the user plan to do left or right or both or just right. So this is a multiple meaning issue that honestly no one can really resolve unless you have like a touch screen that you actually touch it. And of course, this is another like a very pronounced issue that we have is that every time we try to do some project in gesture recognition, 2D or 3D, everyone immediately says, you know what, I have this. Yeah, I want to tap. I want to tap. It's in midair. Okay, tapping is good. It's really good. The only issue is it's that you don't have the actual feedback that you have here when tapping the phone, right? So this could be an issue, not always, sometimes, because you don't know when it ends, and the user doesn't know when it ends. So that's a little bit vague. And vague things are not good. Also, zoom in and zoom out. So I had a request once from a project manager from a mobile manufacturer, and he said, I want you to do this, zoom in, zoom out, which is good. You can do that, but let's assume that the user is doing this, and now you want to stop doing the zoom in. What does he do? Like, that's it, you're stuck. Otherwise, you change the zoom. So let's do a quick summary. Okay, I hope that you're doing good in time. Quick summary so far. 2D data from the camera can be really unexpected. You can get different crappy image quality. You can get a different frame rate. So you can't really expect to get anything. User will not follow your instructions. That's it. Forget about it. User, I'll say it again, user will not follow your instructions. Last but not least, this is an important thing. If a 2D engine works properly, meaning that it overcomes all the huge amount of technological issues that you have, the UX challenges are common for both the 3D and the 2D system as far as it goes to the gesture control. Okay? Okay, no questions, so we can move on. So let's put it all together. Taking everything now that we heard, so what would be the wise strategy to develop something that actually works? So one thing, since you cannot really expect frame rate, you cannot expect continuity in the appearance or illumination through time, try to move as far as you can from taking the temporal or the time consideration into account. This is the optical flow equation, right? For the engineers in account. So try to get rid of that if you can. If you can. Another good strategy would be to increase the amount of static gestures that you have. What is static gesture? For example, if I have a system and I do this and it goes back, this is good, right? It's simple. It doesn't involve all this tracking and clouding. It's a static gesture that do only one thing. Very accurate, less room for errors. Always prefer a gesture that has feedback. This doesn't have a good feedback, right? But this one, on the other hand, has. Even if I don't see, like in VR, I cannot see my hand, still I can feel what I'm touching. So it's some sort of psychological feedback that I'm getting. Yeah, less is more. Less is more. And as inspiring this movie was, it was just a film, right? It wasn't an actual UI that people tested it and it worked properly for all of them. So if you can, take the minimum amount of gesture or interaction types that you can in order to do whatever you want. Not the more. The more is not the better. The less is actually more. Okay, here are some example of real captures that we have from our system. You can see like the tracking or robust tracking under different illuminations of two hands manipulation in real time. The lower one was taken from the Epson BT300. That's another types of interaction. The Jenga is one of my favorites. This is all done by 2D using a 2D camera on cell phones. And again, static gesture detection of like, rock and roll, and heart. This is something we starting from doing like optical flow and segmentation to get like a real full finger tracking of the system, but of the hand. But we sort of give it up because of all of the things that we mentioned earlier on. I won't go into like the business slides. Do we have some more time? 3 minutes. Okay, so would you like to take a question or wanted to try and show like a live demo on the focus? What do you prefer? You have any question? Let's do this. Before. No question. Okay, so want to see a demo? A live demo? I'll try. First time, okay? So no pressure. Okay, so I'm going to switch a laptop, okay? Okay. This one is not needed anymore. This laptop is only for the mirroring, right, of the focus. We don't need it for otherwise because it's an untethered device. Doesn't work now. Okay. Like 1 more minute, it's up, so tell me if I need to stop or 1 minute. Okay. And we're strict, we need to finish in 1 minute or we need to finish. So, yeah.
Here's a question.
Yeah.
Your SDK, can I use that in several headsets with a phone?
Yes, yes. This is exactly the way I was talking about the way you can do gesture control that actually works. So you can multiply it. You can use it with different cameras, different formats. So because we're not dependent on the regular thing, like we don't have like a fit. Yeah, yeah, sure. Sure. Okay, the question, what's your name, sir? Brett. So Brett asked, do I think that eventually, right, eventually will we have like a full working hand interaction system? And I think it depends on the scenario. If you define the scenario strict, doing like very accurate thing without trying to solve everything, then I think the answer is definitely yes.